This particular video is for the IT Fundamentals exam on decimals and binary and how to convert one number into the other. First thing we need to remember is that the decimal system is our everyday number system that we are used to. So in the decimal system, we see the decimal used, right? It's got a little point and it can be used in between the numbers. You will not see that in binary. So when you see any number that's written that's just ones and zeros and there's no decimal, chances are it could be a binary number. Now, the decimal system often has a comma at the hundredths place in each of the different sets of numbers, but not always. So you just have to be mindful. So the first things first is that binary can only be zeros and ones. One means on, a zero essentially means off. This is really important when it comes to networking. So if you tend to think you're going to go into some sort of networking field, this is going to be something you're really going to want to nail down. On the other hand, the decimal system is something we're used to. And that can go numbers 1 through 9 plus, right? So there's so many more numbers when it comes to the decimal system. So let's start with a grid or cheat box that we can use to really understand the decimal system going forward. So to do the grid, we always start with the number 1. Just want to make sure I get it in the screen here. All right. And then we're going to double that number going towards the left. So every number gets doubled as we go. So we'll use this as we're going through the rest of the tutorial. So the first thing to note is that basically what we're looking here are bits. So computers tend to work in bytes and bits, and so you will hear things like an 8-bit system. That's kind of something you're going to want to keep in mind. That's why we have the binary system, right? Data is transferred in ones and zeros, and so we need to just be able to convert our normal way of thinking into how computers think. So let's start with how to take a binary number and make it a decimal number. That's a little bit easier. So we're going to just randomly write here a binary number, right? So 100101. Each of these characters can be lined up against my grid here that I've put up here. And so the way I can figure out if this binary number equals a decimal number is to line them up with my cheat sheet here. And now all I have to do is add where there's a 1, the numbers. So in this case, I would add 32 plus 4 plus 1. And that would tell me what my decimal number, this binary number, equals. So 32 plus 4 is 36, plus 1 is 37. So this binary number written out is 37 in the decimal system. We'll do one more just so you can understand. It is possible to go past the 64. For the purposes of this, I'm just trying to keep it simple and not go numbers that are too much higher. But let's do one more. I'll use the 64 this time. Maybe I'll go with 0 there. So now this is a larger binary number. So now we've got to think about, great, where are my ones? And then what numbers am I adding? So in this case, we're going to add the 64, then the 8, then the 4, then the 2. And that's going to give us what the decimal number is for this particular binary number. So in this particular case, we're going to add 64, we're going to add 8, we're going to add 4, and we're going to add 2. So right here we have a total of 14. Add that to 64, I should have 78. So my decimal number here is 78. So it's much easier to take binary and convert it into our decimal system. But what happens if we're trying to go the other way? And this can be a little bit harder. So let's look at 78 again. Now, if you remember what I just had down on the whiteboard, then you'll know what the ones and the zeros were. But let's pretend that we haven't seen that binary number yet. So how do we figure this out? The first thing we need to do is figure out which of the numbers in my grid up here is the largest number that will fit into the decimal number I'm trying to convert. So in this case, the largest of these numbers that fits into 78 is going to be 64. So I'm going to put a 1 under 64. Now, that's great to know, but now what do? What I have to do is subtract 64 from my 78. And when I do that, I now have the number 14. Okay? So what's the next largest number that fits into 14? Because that's what I have left over at this point. So 16 is too big. 8 is going to be the next number I can use. So I'm not going to use 32. I'm not going to use 16, but I am going to use 8. So now with my 14, I'm going to make myself some more room. So my new number is 14, right? So now I'm going to use that 8. So now I got to subtract the 8, all right? And at this point, now I'm left with 6. And so, put my camera back a little bit. Now I got to do the same thing. What's the next largest number that fits into 6? In this case, it would be a 4. So I'm going to use the 4. 6 minus 4 gives me 2. So I need to find the next largest number that fits into 2, which is 2. And now I have nothing left. So I'm going to put a 0. So when you're trying to convert from binary into the decimal system, what you're trying to do is figure out what number in your grid. And again, this grid can keep going. So the next biggest number after 64, if I double 64, I get 128. From 128, I could get 256. So it just keeps doubling and gets bigger. So if you end up with larger numbers, you can keep converting. But I'm not going to have you guys go much larger than 64 or 128. So Again, the trick is take the number that you're trying to convert. In this case, it was 78. Find which number in your chart, your cheat sheet up here, fits into 78. That's the largest number that fits into 78. And that's the first number you're going to use. So let's use another example. So what if our number was 63 that we're trying to convert into binary? So here's how that would look. 64 is obviously too big. It can't fit into 63. It's just too big. So the first number I'm going to be able to use is 32. So I'm going to use the 32. So I'll draw a 1 under it. And now I'm going to subtract 32 from the 63. All right. Now I have 31. Great. That's my new number that I need to play with. So now what's the next largest number that fits into 31? Well, that, of course, would be 16. So now I'm going to take 31 and subtract my 16. All right. The marker's not drawing here as well as I would like. All right, so now we have 15. That's my new magic number. The next largest number that fits into 15 is going to be the 8. So I am going to use the 8. I'll put a 1 there. We're going to subtract that 8 now. Subtract 15 from 8. I'm going to have a new magic number of 7. Now, with 7, my next largest number I can use is a 4. So we're going to use the 4, put a 1 under it. Let's subtract 4. I'm left with 3. 3 is now my new magic number. 2 does go into 3. So I'm going to use the 2. I'll put a 1. And now with my 3 here, I'm going to subtract 2. That leaves me 1. So in this case, we actually used every single one of the numbers up at the top. And if I was to add all of those up, converting that binary number of 111111, if I tried to convert this into a decimal number, I should end up with 63. So if we were to add 32 to 16, we get 48 plus another 8 is 56, 57, 58, 59, 60, 61, 62, 63. So I can tell you that we've done the numbering right because 63 is what I'm going to get. So that's the easiest way I can teach you to convert a decimal number into a binary number, or vice versa, right? Here's the binary number I just ended up with, and anytime there's a 1, I add the numbers. So in this case, I added the 32, the 16, the 8, the 4, the 2, and the 1, and I got to 63. Now, one more thing I want to throw out there that you have been learning about in chapter 2 is hexadecimals. And really what they're talking about with hexadecimals is when you have a very large binary number, lots of ones and zeros. So let me just put one down here just for the sake of what happens when this huge number of 12 characters, and I don't have a chart maybe like this that goes up far enough, how do I then take this and convert it into something a little more readable? And so what IT folks have done is convert any number that's above 9 into a letter. So you're going to say, for example, the number 10 is going to be A. The number 11 is going to be B. The number 12 is going to be C. So if I was to look at this large number, for hexadecimal readings, what they do essentially is they start on the right-hand side and they group that binary number by 4s. So they've basically chunked that huge binary number into 3 sets of 4. So now I'm going to read the binary number and try to figure out what it is and if I need to convert it into a hexadecimal number. And so some of these may, some of these may not. So let's play around and see what we get here. So for this first one, again, if I line this up on my grid, I'm only using the first 2 numbers. So this would just be a 3. In this second one, I'm going through 4 different numbers, but I only am using this number here. And so in this case, this would be 8. But on this one, I'm using all 3 out of the 4 numbers if I lined this up. So in this case, I'd be using the 8, the 2, and the 1. So 8, 9, 10, that would be 11. So now we've got a number that is greater than 9, and so I would have to be using the hexadecimal system. So in this case, I would be converting this because this number is 11. I would need to convert whatever 11 is to a hex. And so again, if I'm thinking this through, A is 10, B is 11. Just trust me on it. Don't have to know why. It's just an easier way to write it. And you can't go up any higher in a group of 4. That's why you only go to F at this point. Okay? But in this case, that last number that I'm looking at here, if I added this up again, it comes into 11. So this would be B. So if I was reading this binary number as a hex number, that would equal B83. And typically we like to have things in groups of 4 for hex, so I would most likely put a 0 in the front of that. But that's the hex system as well. So grouping up your binary numbers, and that's why if you see the A, B, C, D, E, F, you're going to see some stuff like that. All right, hopefully this makes things a little bit clearer, and we'll do some more practice later.